absent on Thursday after we get back from break because I got to go to one of those unbelievable trainings that's going to make me better as a teacher. Been doing it the same way for 29 years, and apparently it's been wrong for 29 years. All right, we have 3-7 out. Let's take a look at that. 3-7. See how we do with this. All right. Problem number 1. Everyone got it out? If your neighbor doesn't have it out, shame them. Public shame. All right. So the data set is given with a mean of 50, standard deviation 9. Find 2 mean standard deviation after each transformation. And then, we're actually going to get into like some probability stuff today. Like, finally, we'll be just doing all this stat stuff. All right, so problem number 1. Hey, what page is that? What page are we on? 81? Thank you. 193? 193, okay. All right, so they tell us we originally have a mean of 50 and a standard deviation of 9. So if we add 15 to the data set, this changes our new mean to this. And it keeps my standard deviation the exact same. Okay? So if you add or subtract, standard deviation doesn't change. Just the mean would change in this case. All right, number 2 says every observation of the set is tripled. Okay? So if it's tripled, we times by 3. So I'm going to take my original mean, and I'm going to multiply by 3, and that gives me a whopping 150. I'm going to take my standard deviation because we're multiplying. We're going to go 9 times 3, which is going to get me 27. Okay? And then problem 3, let's squeeze it down here. It says we double and then subtract, and then we subtract 20. Okay. So if we double it and subtract 20, I'm going to go 50 times 2 minus 20. So that's 80. And then my standard deviation, the only thing that changes on that is the doubling part. Okay, so the addition or subtraction does not affect the standard deviation. That's pretty easy cheesy. Watch, you even got the exact same bottle.
Oh, I know.
Oh, yeah. This was a delicate issue.
Yeah. There was tears.
There was tears? I'm sorry. I had grabbed that bottle and I hid it from you on purpose.
I think I did for you.
Yeah. I only do stuff like that to my wife. Just to mess with her. Where's the vacuum? Oh, you got rid of it. I need you to vacuum the house. No, it's gone. True story. All right. Down below it says a psychology class gives a quiz worth 20 points, assuming that you score a normally distributed class average with 16, standard deviation 3. The teacher has chosen how to transform the curve. So they're telling us that we have a mean of 20 and a standard 16, sorry. 16 standard deviation is, help me out, I can't find it, 3. All right, well, I forgot to dim the lights. Let's light candles now. I'm sorry. It's because my dad calls me son. Oh. Hey, where's your book? Man, don't worry, you're not the only one. Watts, why does your neighbor not have her book out, huh? Hard day? You lost your book? You lost your car? What? Oh, go get it. Bring back Dr. Pepper for everybody. All right. Problem number 4, doubling every score. So doubling every score. So I take the mean, go 16 times 4. So that's 64. Standard deviation is going to be 3 times 4, which is 12. Then B, add 50 to each score. So the mean becomes 16 plus 50, which is 66, and the standard deviation stays the exact same. And then C, no, it's not doing yellow. C, if we multiply each score by 5 and then subtract 10, so my mean is going to be 16 times 5 and then minus 10. 16 times 5 minus 10. I got a calculator here. Good thing. 16 times 5 minus 10 is 70. And then the standard deviation, you only do the multiplication to the standard deviation. So that's 15. Okay. Hey, you guys want to hear something that's kind of cool? I got to can I brag on my oldest daughter for a moment? So she's at KU at graduate school. They will pay for her to get all the way through her PhD in forensic geology and anthropology, which is basically kind of cool. She's like not sure if she wants to do the PhD. She's thinking just master's. I'm like, dude, someone's paying for your PhD. Please get it. So we'll see if she gets it or not. But she went out to basically what her job will entail later in life, or one of her jobs it could entail if she chooses to do this, is anytime they are doing a major construction project, if they come across something obscure as far as rock structures, or if they find remains of an indigenous tribe. So I kid you not, this could change about everything. What was discovered at a site in Colorado, because she came out to Colorado with her team last week, and down in Lone Tree at the end of the light rail line, you know, on the opposite side of the highway from the hospital that's down there, I-25, they found human remains that date back 14,000 years. Now, where this changes things, if this truly comes back, they have to take it back to the tree lab because they just did an on-site check. But if this truly is accurate, y'all heard about the Bering Strait in Alaska, how Alaska and Russia used to touch, and tribes came over and they would follow the herd that they were hunting. If this holds true, this changes that, because basically over the Bering Strait was 3,000 or 4,000 years ago, and if they found human remains that were 14,000 years old, that changes everything, meaning that there could have been tribes here much longer than what it originally thought. So I thought that was kind of cool. So, and like, dude, my daughter figured that, well, she wasn't hers, her whole team figured it out, but I thought that was kind of cool. So who knows? Who knows? Maybe when you guys have kids, you're like, yeah, we used to learn about the Bering Strait, but because of Stirrup's daughter and her team of geologists and anthropologists, they proved it different. Darn, that'd be kind of fun. All right, so that was commercial break for Stirrup. Just give you some fun information. Maybe it's useless to you, I don't know. If the teacher multiplies every score by 5, what percent of the students will get a 90 or higher? Ooh, okay. So we're going back to this problem that they said that the average was 16 and the standard deviation was 3. And then they said if the teacher multiplies by 5, what percent get a 90 or higher? Uh-oh. Starp's going to go back and change a few things. All right, ready? So if we're multiplying by 5, x bar equals 16 times 5. 16 times 5 is a 16 times 5 is an 80. So the new mean changes to an 80. The standard deviation changes from 3 times 5 becomes a 15. All right. So this basically means this. 80, one standard deviation to the right, puts it to a 95. What percent get a 90 or higher? Gee, friends, what do you suppose we should do here? That's the rough version. We just had a quiz on it. What do you think? What do you think we should use? Bet you know. Desmos. Which part of Desmos? I like this thinking. Normal distribution. Cool. And we know it's normal distribution because basically above they said that it was normally distributed. So jump on to Desmos using 80, 15. Hey, there's my email. Any of your parents' email? I don't know. All right, Desmos. Okay. Normal distribution, right? And what was the average? 80, the new mean? And then 15 was standard deviation. Cool. So this is our new normal curve based on that. And we want the percent of students that get a 90 or higher. Minimum 90, maximum infinity. Wow, look at this. Because that teacher curved it, 25.2% of the students are going to get an A. I like that kind of curve. That's usually when we're in our PLCs and you're like, you shouldn't curve it that much. Kids shouldn't be doing that well. It's like, come on, who cares? No, seriously, you don't want to give these kids a false sense of hope they might be successful in life. Sorry. Kid you not, I've been in meetings where you get people who are pissed off at the world that they're a teacher. And then you got the rhinestone cowboys like, dude, this is our future. It's looking good. All right. So, number 6. We changed it up a little smidge. We're going to get away from, we might be able to do this on Desmos, but maybe not. All right. So, number 6 says that we're going to add 80. All right. So, number 6 says we're going to add 80. So, that's going to change our mean. It's going to go from 16 plus 80. That's going to go to 96. But the standard deviation doesn't change. It stays at 3 because we do that. Okay? All right, so this is one heck of a curve. 80 and standard deviation 3. 80 standard deviation. Or wait. If he adds 80, so it's 96. I'm sorry. 96. 96, standard deviation 3. What percent gets... Hey, that's one heck of a curve. That's a stirrup curve right there, my friends. Look at that. You got a 97.7% of the students that get an A. That's what I'm talking about. I don't know about you guys. They shouldn't give kids that kind of gift. They don't know what they know. They don't know too much. Next generation, you're sitting on their phones and they're just playing games on their phones. Yeah, and we wouldn't. What was I doing during class? Kid you not. You guys want to hear about Mr. Hashem, 7th grade history? Yes. You want me to mimic Mr. Hashem, how he taught our 7th grade civics class, social studies? Okay. We'd come walking into the classroom, Wallen Rose. You still with me? Mr. Hashem would come walking in. He had those, so I'm making fun of me. He wore glasses like me, but like I got trifocals in here, but because of technology, my lenses are pretty thin, even though I have a bad prescription. Back in the day, he had those big old Coke bottle things, probably weighed about 4 pounds on his nose with his glasses. And Mr. Hashem would come into class and stand in front of this. This class is officially called to order. I will take roll at this time. Mind you, friends, I'm in 7th grade. You remember the whole weird middle school social experiment years ago for you? Like this doesn't work for 7th grade boys. Okay, in my class, okay, you got Chris Stirrup. I was the best behaved of the kids. And I wasn't a real good kid. We had Brad Herman. Brad Herman had made it, he'd gotten arrested like 6 times already. Been in juvenile hall for weeks. Juvenile hall was like, bad kids. Adam Alvarez. Adam Alvarez, I think, started smoking pot when he was in 1st grade. Charlie Moreno. Charlie Moreno probably beat up more people than the summation of all the MMA fights that have ever taken place. Francisco Reese. He was probably one of the biggest drug dealers to ever cross Tempe, Arizona when he was in 7th grade. Mike Quarters. You couldn't take Mike Quarters. He would just make people cry by looking at him. Now, then there's Bobby Duane. You'll hear about Bobby Duane during the Orange story. That'll be spring break. Bobby Duane, she was the bad girl. Okay, she was like the Brad Herman version, but she didn't go to juvie. Okay, Bryce Shepard. He had a flatulence problem. You remember the kid in elementary school and you walked in the classroom going, oh man, this is going to be a good year. We ain't going to learn nothing, but it's going to be a good year. Bryce would fart nonstop. Okay, now you're in 7th grade and you got to do that kid on demand, make you hear around the room. Okay, who else am I missing in this class? Eddie Forshee. He was the dude who thought he was like this top-notch athlete, but he sucked at everything he did. Like when he played soccer, when he played football, if you want a position he played football, end, guard, and tackle. He sat at the end of the bench, he guarded the water, and tackled anyone tried to take it. That was Eddie Forshee. So needless to say, we have this teacher that says this class is officially called to order. Now, if you talked during Mr. Hasham's class, he would assign you 100 words. Meaning, you had to go home and you had to open up the newspaper because all of our parents got the newspaper back in the day, and you had to find an article and you had to write out 100 words of that article in the paper and give it to him. That was your punishment. Okay, so you got 100 words. Talk again, you got another 100 words. There was kids walking out of that class daily with 45,000 words they'd have to write out of paper. I mean, that's another 100. That's another 100. That's another 100. You want to put that's another 100. I mean, I can tell you that I didn't learn history in this class, but when the people like me who don't, or people like me who understand people like you, versus the people like me that don't understand people like you. So what did we do in class? Well, it started out with flicking staples. Okay, get a thing of staples, you break it apart, fling it across the class. You know what I'm talking about? That was kind of fun. Anyone got a penny on them? You got a penny? Let me show you this neat trick I learned in 7th grade. So it went from staples. Staples, you weren't able to distract people. Well, I'm so sorry. You weren't able to distract people well enough. All right, my baseball boys. Who's got the best hand? Good catch. Anyway, here we go. Ready? Ready? Nuts, isn't it? Oh my gosh, yeah. There we go. So teacher would be up front. Start would be sitting about right here. See the normal curve up there? That's the teacher. All class long.
How many days did you have?
Oh man, everyone back in the day had a bucket full. They all had a bucket full of pennies. It was just warfare in class. Mr. Hasham didn't know what to do with us. Then it got beautiful. So there was one day, Adam Alvarez, he had the kid smoke pot since like 1st grade. You know what I'm talking about? Yeah. Adam Alvarez walks into class and he's holding an M80 firework. He's walking into the class. He lights it. It's got the ultra slow burn fuse on it. Puts it right in front of the teacher's desk. Goes and sits down. This class is officially called a boom. Yeah. Friends, I kid you not. That was 7th grade history. So, and the people like, you can't trust what these kids can do today because they're just looking at their phones doing something. Like, you kidding? I would go through $1.50 in pennies a day in civics class. Just wing, wing. He probably could have retired with the amount of pennies we flung at him. It was crazy. So, Mr. Hashem, I mean Mr. Jenkins, drive. Huh? Can you snap? There you go. Put it on the edge. Snap. What you do, if you line it up down your elbow, you snap it right. But if you have a sleeve like this, you just shoot down your arm like, oh, dang it, I got to refire. Well, if it goes down your shirt, Hey, just so you know, you guys flick pennies at me, I flick them back. That'd be fun. All right. Hey, Mr. Jenkins drives to work. Takes an average 38 minutes, standard deviation 8 minutes. Oh boy, Mr. Jenkins. That's Eden's dad, isn't it? Okay. All right, we can do this probably pretty easily. So far, we know that Mr. Jenkins 38.8. All right. Here's Mr. Jenkins' distribution. If Mr. Jenkins is pulled over by the police for 15 minutes exactly, what is his new mean and his new standard deviation? Well, we're subtracting, so normal distribution, I go 38 minus 15, right? Comma 8. All right. There's his new one. The blue is his new standard deviation. Yeah.
Are we adding? Because it's adding 15 minutes.
Oh, we're adding, right. Oh, thank you. Thank you. Adding 15 minutes. We got to go this way. There we go. Move it to the right. All right, so notice from the red to the blue, all it did was shift. The normal distribution looks the same way. Then it says construction is doubling his commute time. Okay, I don't think we're dealing with the getting a ticket on this one. So if we're doubling his commute time, that means I'm going to multiply this times 2. So that's going to be, I multiply by 2. Let's go. Doom, doom, doom. So I'm going to go 38 times 2. And if I double that, that means my standard deviation gets doubled. So 8 times 2. Okay. Oops. 8 times 2. All right. So I can't even see it now. Okay, so basically if you wanted to see what the difference was between them. Okay. The red was the original one. Look at what they did with the blue because I doubled it. It totally shifted it right by a factor of 2, but it also spread out the normal distribution. It made it shorter as well. Yeah.
I think this is 138.
Yes, it does. 38 times 2. I'm glad there's people in here that weren't in Mr. Hashem's class. All right. There we go. Nope, do that one. So the reds are original. The blue is the other one. Notice it shifts to the right by a factor of 2, but it also spreads out. Okay? It's not as tall. Is it half as tall? I don't know. All right. Mr. Jenkins starts work at 8 a.m. sharp. If he leaves at 7:20, what percent of chance will he make it to work on time? Okay, so we're going back to the normal distribution. So he leaves at 7:20, needs to be here at 8. So let's see. I need to go back to my other one. So my first normal distribution, let's not worry about this. All right, so this 38 minutes, let's see, it takes him 7:20 to 8 is 40 minutes, agree? So if I go back to this normal distribution and I say, what's the chance he makes it within 40 minutes? Actually, I'm going to do it as my max. My min is this. Mr. Jenkins has a 59.87% chance of making it on time if he doesn't get pulled over, doesn't have a construction. If Mr. Jenkins gets pulled over by the police officer on the way to work and leaves at 7:20, what percent chance will he make it on time? He got pulled over by the cops. What did we added to it, didn't we? 38 plus what? 38 plus what? 15. All right, so if Jenkins gets pulled over by the cops, so 38 plus 15 comes out to like 53 standard deviation 8. Mr. Jenkins now has a 5-point-something% chance. Can't see it. He has a 5.2% chance of still making it on time. Okay, so there is a chance. And then if Mr. Jenkins leaves at 7 a.m., gets pulled over by the police, and construction is doubling the time of his commute. All right, so he gets pulled over by the police, and construction is doubling his commute. Times 2. And then I have to multiply this times 2. And then he leaves an hour early, so he leaves at 7, right? So he has an hour, so make that 60. So if Mr. Jenkins takes himself an hour to get to work because he realizes there's construction, also gets pulled over at the same time, Jenkins has he has a 2.6% chance of making it. All right. Hey, you guys ready for National Day of Turkey?